So, as we saw previously, and as you've probably also reflected on, structure can contain any objects, which means that the overall structure of any multidimensional container uh, is completely up to you. You could have a list in which the first item is a list, the second item is a dictionary, the third item is a set. Really, it's up to you how you want to structure your data. What we're going to focus on are some standard structures that you may need to build, and that makes sense in terms of the data that we're reading. The data that we're reading, of course, generally comes from two-dimensional sources. That doesn't always need to be the case by any means, but it is what we're focusing on because we already understand the structure pretty straightforwardly. Now, if you look at this code, and you may want to pause it and see if you can figure it out for yourself before I begin explaining it. That's the pause where you get to pause the video. I think you can see that we're looping through each line in a file. Here's an interesting idiom. I just took there's like three different objects involved here. We've got the file object coming back from open. We've got the string object coming back from read. And we've got the list of strings object coming back from split lines. And we're able to chain these together because open does return a file object. You can call read on that file object, and then of course you can call split lines on that string object. And so we're just saying for each line in that resulting list. It's kind of interesting. We're splitting the line. As you know, a split returns a list of strings. So this is a list of strings from the line. And again, looking at this, you know this means it's going to be a 5-item list. We're then taking that list and appending it directly to the outer list. So this is just a simple way to do this. And as you can see, it's not really any different, except in one small aspect, from the loop through and append algorithm that we've been using previously in the past few weeks. We're simply creating a list and appending it as an item. So, of course, what this means is you need to mentally consider, oops, I don't think I have abbreviated. I'm going to use tiny. Mentally consider what sort of structure you want, and then imagine it being built as you loop through your data. Here you can see we've got a list here as the first item, second item, etc. So you can see it's really very straightforward to do this kind of thing. Let's look at a slightly more complicated structure. In this algorithm, we're going to build a list of dictionaries. Now, you may ask why we might do this. We should look at the final structure, perhaps, before we answer that question. Here, I'm just going to print outer list. In fact, why don't we begin by just looking at the structure? Well, actually, I take it back. This is going to be a bit messy. So let's look at the code first, and then we'll look at the structure. Again, you may want to pause this and take a look at it to see if you can see what's happening here. But basically, all we're doing is very similar to what we did with the list of lists. We're basically just saying for each line in this file, let's make a dictionary. And with each dictionary, let's append that dictionary to an outer list. So we know from just that assumption that we're going to see as many dictionaries in this list as there are lines in this file. And if you look again at the code, you can see that for each line in the file, we are splitting the line, then creating a dictionary inside. There's no need to create an empty dictionary and then add each key and value one at a time. If we know that the dictionary is going to be completed in this one iteration of the loop, if we know that this dictionary is going to be completed or can be completed with all the data that we have available to us, then there's nothing really stopping us from just creating that dictionary in code and then assigning it to the outer list, or assigning it to a name and then appending that to the outer list. Now, the result, as we saw when we print something like this, is pretty messy. But let's use a special tool that I want to make sure you understand how to use. When you're building these kinds of things, it can be extremely useful to be able to see a clear output. We're going to use a module called pprint. Pprint stands for pretty print. Of course, as you know, when we import a module, that means we're just importing other Python code. Pretty printing is actually a term that's used in the IT world. Pretty simply means not ugly, and ugly refers basically to what we're seeing here. A big mess of braces and brackets that are very hard to get through. Theoretically, you could read this, but why would you want to? When you have something called pprint. pprint.pprint outer list. Let's run that and see what we get. Okay, great. What we're seeing is a much clearer view on our structure. It's not always going to be perfect, and there are actually ways to configure pprint to allow for a certain width, certain amount of indent. We're going with the defaults here, and that should be fine. If you look closely at this, you can see that it is indeed a list. A list of what? It's a list of dictionaries. So this may remind you of one of the structures we used when we were reading a list of dictionaries. So you can see that each row from the table was built into a dictionary. Now, a question I often get is, why is this? Why do we want this? Why do we even care to do this? And the answer is convenience. If we have a list of dictionaries in this way, and I wanted to access, let's say, each column, yeah, I could use a list of lists and then use a subscript on each list. I could even loop through the file and just print out each column. For example, maybe I just want to see all of the dates. But if I've built a structure like this, it can be really easy and useful to just say for ID, I'll say IDICT in outer list, print IDICT market ref. What I'm allowing myself to do, and when we print this out, we should see all the market ref values. But we could also do that with date or anything else. What I'm allowing myself to do is treat each row as if it were, treat each row as basically a dictionary, which means that I can use the labels. I can use the keys to get this to happen. It's very convenient to me once it is built. And although it may seem like a lot of extra work to maybe make a list of dictionaries, it really isn't. We're simply creating in one row only. I mean, one for every iteration, but we only need to do it one time. We're creating a nice labeled dictionary that just makes it real easy for us to work with this stuff. Obviously, we could have done it as a list, and I could have just maybe appended columns to my outer list. See what I'm doing here? Columns is what came back from Split. This is what we did in the previous iteration. And then I could just use, let's say the index of the column that I want, and I should end up getting the same result. And yes, sure, I can do that. The only problem is if I want to, deal with multiple columns, I'm going to have to keep all those indices straight. So if I was, for example, although I wouldn't want to do this, interested in adding together the first and let's say the last column from each row, yeah, I can do it, and I can use the indices, and the indices may be clearest to me. That might be what I prefer. But if I'm not interested in that, if I don't feel like trying to keep these columns straight, then I can just use the column head, and that's going to be making it much easier for me to handle these values in each row, because I can use a column head. And this is a structure that you can also sometimes get a database to return where it gives you back a row that is a dictionary, because it's just very convenient. You don't need to remember, or imagine that the table was 20 columns wide and most of those columns you're not interested in? Are you gonna look at this, large file with 20 columns and then start counting 0, 1, 2, 3, 4 until you get to the 16th column and say, oh, I see, it's index 15. Got it. Or wouldn't it make more sense to use a list of dictionaries where you can refer to a row by its column head? I would argue for the latter.